Good morning, everyone. My name is Mrudula, working as Assistant Professor in the Department of Electrical and Electronics Engineering at MLR Institute of Technology, Hyderabad. Today, I am going to discuss few topics from the subject called Industrial Electrical System. These are the topics like why protection devices are needed and what are the electrical accidents which may be caused and the protection devices which are used to avoid these electrical accidents. Some of the devices are like fuse, MCB, MCCB, ELCB, and next topic is comparison between the different circuit breakers and inverse current characteristics of a circuit breaker. Why electrical protection components are needed? Protection components are essential to protect against faults. Faults may be an open circuit or a open circuit or else a closed circuit, short circuit. Second one is reduce secondary damage. When the fault is not detected, the secondary damage may cause. Next one is to prevent static shocks and lightning from damaging the small important parts that run or control the electronic devices. Small parts which control the speed, like example is speed, control the speed of an electronic devices. Those devices should also be protected. Next one is to ensure the operation. Ensure safe operation by following the all rules of standards like IEEE standards, IEC standards and UL standards. Next one is some of the electrical accidents which may be caused. Like first one is electric shock when a person is in contact with the source. Second one is electrical fires which may be caused by faulty wires or switches or faulty appliances which are not grounded properly or loose sockets. Next one is extension cords. Extension cords capacity should always match the appliance. Should always match the appliance means based on the appliance the extension cords should be designed. Next one is faulty wiring. The faulty wiring may be visible or invisible fault. Next one is electrical overload. This occurs when too many devices are being connected to the same socket or same box. Next one is electrocution. Electrocution is nothing but electrical hazard caused due to flash, flame or lightning. Next one is electrical cords near water. This is a dangerous combination. Electrical cords should be always very far from water as well as the humidity also. So the next one is protection devices which are used to avoid the above electrical accidents. The devices are like fuse, MCB nothing but miniature circuit breaker. Next one is MCCB and ELCB. All these four are different types of circuit breakers used as protection devices against these electrical accidents. Next one is lightning arresters, surge arresters and relays. At different points of distribution or transmission of the power, we use all these different types of electrical protection devices. Now, we will see few of the devices. Like the first one is fuse. Fuse is an electrical safety device that protects the circuit from too much of current. It means a metal. Here you can see a wire. This is a low melting point wire. Low melting point wire which breaks the circuit when too much of current flows through the device. When the current through the device increases rapidly, this particular wires melts and it breaks the circuit. Means circuit will be open circuited so that the remaining circuit will be in a safe hand. So this particular fuse is used for small voltages or low voltages. This second one as well as the third type is used for high voltage appliances. Second device is MCB. MCB is nothing but miniature circuit breaker. Miniature circuit breaker is an automatic electrical switch that protects the circuit from excess current, short circuits and overloads also. MCBs are mostly used for houses and commercial buildings and industries also, but low capacity industries, small industries. For small industries, for homes and for commercial buildings, we will be majorly using this MCB or miniature circuit breaker. They are installed in electrical panels and lighting systems to ensure the uniform distribution of power and limit power fluctuations. That is, to limit the power fluctuations and for stable distribution, we will be using these MCBs which are being installed in panels and lighting systems. Next device is, here is the picture of MCB where this particular picture is a 3-phase MCB and these three are single phase. These three are single phase MCBs. This is a 3-phase MCB and these three are single phase MCBs. These single phase MCBs are again connected to this 3-phase ACB. First one is R, second one is Y, third one is B. So the 3-phase system is there where R, Y, B are connected to the single phase MCBs. And this is also connected to neutral. This is also connected to neutral. This picture is nothing but the 4-pole MCCB where there are 3 poles, that is R, Y, B as well as neutral. This is a picture of MCCB and this is a picture of 3-phase MCB and this is the picture of single phase MCB. This is another picture for knowing the MCB where the house is being connected to this changeover MCB, connected to a changeover MCB. That changeover MCB is connected to DP MCB. DP is nothing but double pole MCB. Here this double pole MCB is connected to the generator. So the generator is connected to your house via the changeover MCB and after that double pole MCB and then to the generator. And this changeover MCB is again connected to one more DP MCB which is being connected to this electrical meter which displays the units consumed per month. Next, this particular electrical meter is again connected to the electrical pole. So this is the picture for MCB. Next one is MCCB. MCCB is nothing but molded case circuit breaker. Nothing but molded case circuit breaker, which is an electrical protection device that protects the circuits from excessive current that may cause short circuits or overloads. MCCB are more durable and have more features when compared to the MCBs, that is miniature circuit breaker. So, MCCB is more preferred when compared to MCB. Now, MCCB are commonly used in industrial and residential settings. That is, MCB will be used for small industries, and for bigger industries we will be using the MCCB because the features are more for MCCB compared to MCB. This is a picture for MCCB, where here you can see the MCCB, which is a 3-wire, that is RYB, 3-phase, and the last wire is neutral one, which is connected to a TPN here, which is connected to a TPN. TPN is nothing but triple pole with a neutral. Triple pole with a neutral miniature circuit breaker. Means this is also a kind of a circuit breaker which is known as triple pole with neutral, because there are 4 lines here, that is R, Y, B as well as N. So this MCCB is connected to the triple pole MCB and then to the starter, which is being connected to the motor here. So, to connect this MCCB to the motor, we will be using a TPN in the middle, and next the motor starter and then to the motor. This is another picture for MCCB. Here you can see the MCCB with 3 wiring, that is R, Y and B. This is being connected to a magnetic contactor. MCCB is connected to a magnetic contactor, and that is connected to this overload and then to the motor. Here you have a start switch and a stop switch, which is being connected to this magnetic contactor to operate the motor. So, to operate the motor, we need a MCCB as well as this magnetic contactor with a start and a stop switch for that. Next type of, here you have the comparison between MCB and MCCB. MCB is used for low energy requirements such as small electrical circuits or for home wiring. MCCB are used for high energy requirements and regions such as high power equipment and industries, and for high voltage industries we will be using the MCCB. For small industries or for small home appliances we will be using MCB. This is a comparison between MCB and MCCB. MCB stands for miniature circuit breaker and MCCB stands for molded case circuit breaker. The rated current, maximum rated current is only 125 amperes for MCB, and here the rated current is around 1600 amperes. Its interrupting current rating is under 10 kiloampere, and here the interrupting current is between 10 kiloampere to 85 kiloampere. By this we can judge that the power capacities of MCB is mainly used for low braking, and here MCCB is mainly used for low as well as high braking capacity requirements, mainly for industries. Next, its trip characteristics are normally not adjustable since they basically cater to lower currents because they are connected for the lower circuits, low circuits, it cannot be adjusted. But MCCB, here the trip current may be fixed as well as adjustable also for over voltage and magnetic setting also. So for over voltages, it can be adjusted, but MCB cannot be adjusted. This is ELCB. ELCB is nothing but earth leakage circuit breaker, which is a specialized type of latching relay that has a incoming main power connected through its switching contacts, so that ELCB disconnects the power when earth leakage is detected, mainly the earth leakage. ELCB is mainly used for earth leakage only, and ELCB detects the fault currents from live to the earth or ground wire. Here you can see the picture of ELCB, where in this ELCB you have 3 wiring, that is R, Y, B, and then to the neutral. And this is the picture, internal picture of this particular ELCB, where you can see R, Y, B as well as neutral, which works with a voltage input of 415 volts, 3-phase AC. And here you can see the load which is being connected to the ground. So here there are different pictures of different types of circuit breakers: miniature circuit breaker, molded case circuit breaker, earth leakage circuit breaker, and the last one is residual current circuit breaker. Majorly we will be using all these 4 types of circuit breakers based on the cost and the load. Here there is a comparison between RCCB and ELCB. RCCB refers to residual current circuit breaker, ELCB for earth leakage circuit breaker, and it is a new name and refers to current operated devices. ELCB refers to the voltage operated earth leakage devices. Here it refers to the current and this refers to the voltage. It ensures 100% detection of leakage currents, and this is not preferred as it can only detect the current flow back through the main earth wire. If it is connected to the main earth wire, then only it is used to detect. So RCCB is the better option when compared to ELCB. And from the previous thing, here you can see MCCB is more preferred when compared to the MCB. What is inverse current characteristics of a circuit breaker? The inverse current characteristics of a circuit breaker is the tendency of the breaker to trip more slowly when there is a lower overcurrent, and more quickly when there is a higher overcurrent. Means the overcurrent is low, it will take lot of time to trip, and if the overcurrent is high, it will trip sooner. So this is done to reduce the risk or nuisance tripping for transient overloads. Here how the inverse time characteristics works. It mainly has 3 steps. First step is wait, second step is break, third step is faster tripping. Wait means at lower overcurrents, the circuit breaker waits to see whether the fault is temporary or permanent. Second step is break. If the fault current is still present, means it is taking lot of time. The same current, the current is gradually increasing. Then the circuit breaker breaks the circuit. Faster tripping means the delay time in tripping decreases. Faster tripping means the delay time in tripping decreases as the current increases. So here you can see in this picture the inverse current characteristics. As the overcurrent increases, the time to open decreases. As the overcurrent increases, the time to open decreases, means they both are inversely proportional to each other. So that is why we can call this one as inverse current characteristics. The x-axis shows you the picture of overcurrent and the y-axis shows the picture of operating time. So if the inverse current or the operating overcurrent is less, if the overcurrent is less, the time to trip is more. When the overcurrent is moderate, time to trip is moderate. When the overcurrent is more, the time to trip is very less. So the current is inversely, not the current, the overcurrent is inversely proportional to the tripping time. So today we have learnt about different types of electrical accidents and the protection devices which are used to avoid these electrical accidents. In next session, we'll be learning about topics like single line diagram and different types of components which are used in the single line diagram. Thank you.